Hello everyone, this is Phil from statisticsmentor.com. Continuing with the example on bivariate regression using the tooth growth data now, we're going to focus on dummy variables as the independent variable. Right, so in case you haven't seen the previous video in the series, we have here data, an experiment on the effect of dosage and type of supplement of vitamin C on the length of tooth growth in a rodent after a period of time. So the dependent variable is the length, and the independent variable, otherwise known as the explanatory variable, or other things depending on your field of study. So let's just call it X variable because we all know that it's the X variable. The X variable is supplement, dose, and what we did was regress length on dose, length being continuous and dose assumed to be continuous, and orange juice is not continuous, it's categorical, so we ran two regressions, one for orange juice supplement and one for VC supplement. Okay, and then the question was, does there appear to be a difference on the effect of the supplement on the relationship between dose and length? And the answer appears to be yes, because the fitted line is not the same. You can see the intercept for here will be different if we project it back. This is not actually the intercept because it doesn't start at 0. Except we're down here somewhere, and here will be less than 15, and here will be less than 9 or whatever it is. Okay. Moreover, the gradients are different as well. Now if we're to get the fitted lines, we see that these are the equations. For orange juice, the fitted y, the fitted length here, has intercept 3.3 and a slope of 11.7 on dose, whereas for VC the slope is lower at 7.8, which tells us that the length is more sensitive to a unit increase in dose for orange juice supplement than for VC supplement, because this slope figure is higher and is bigger than for this one. Okay, but then we conclude in that video saying you can't just run two separate regressions to compare the differences in groups. The way to do it is to run one regression with a dummy variable to account for the fact that we have a categorical X. Okay. Now this isn't supposed to be a lesson in dummy variables, but just to recap, when one of our X's, the independent variable, is categorical and has K groups, we set up K minus 1 dummies. That is the usual way, but not the only way. But I want to keep things simple, so I'm going to do it that way. Here we supplement as comes in two types, VC and OJ, so that means we need to set up one dummy variable because K is 2, being VC, OJ, so K is 2. We need to set one dummy variable. And all dummy variable, another word for dummy variable is indicator variable. All dummy variable does is it's coded 0 or 1, column of zeros and ones. 0 meaning no, you're not in this particular group, 1 meaning you are in this particular group, depending on how the dummy is defined. The coefficient on the dummy helps us to compare one group, the group that is coded 1, to the group that is coded 0 on the impact on the DV, dependent variable. Now, how do we then set up a dummy variable for supplement, because it's at the moment it's not coded 0 or 1? Well, one thing is we can put this supplement directly into our regression in R, because the nice thing about R is that as soon as it sees us that we do not have numbers here, we have text, it treats it as, if it was categorical in its terminology, it treats it as a factor, and it would generate automatically dummy variables for you. So if I do this, let's call the regression R1, length on dose plus sup, so I put it straight in, it will automatically create dummy variables, so code one at 0 and the other one as 1. But which does it code 0 and which code 1? That's the thing, we can see that later. So here is the regression output, sup VC minus 3.7. So the difference in the intercept, this is the intercept dummy, the way I put it in, saying that the difference in the intercept is 3.7 for the thing that's coded 1 to 0. To see what has been coded 1, 0, we can look at the model matrix for the regression. So type in model matrix for R1 regression. We see that 1, so here is the column we're looking at, 1s from observations 1 to 30 and 0 otherwise. If we look back at the original data, we can see that corresponds to VC, because VC is the first 30 rodents, given to the first 30 rodents. In other words, the way it's been coded here is 0 if it's OJ, 1 if it's VC. So the way we interpret this figure number here is that the intercept, if you're in the VC group, is lower than for VJ by 3.7. So if we look back at our picture, it's saying that the intercept for VC is lower than for VJ by about 3.7. Is it significant? Yes, because the p-value here corresponds to the t-statistic testing the null that is not that the coefficient is 0 is rejected, and since its p-value here is less than 0.01, we can conclude there's very strong evidence against the null. In other words, it's highly significant. All these jargon I'm using is not to confuse you, but there's so many ways of saying these things. Anyway, let's just say that it's significant. What the heck does that mean anyway? It just means that across any level of dose, the length of tooth for a rodent taking VC for a given level of dose will be lower than for VJ. Alright, and that is the intercept dummy. But we can see from the picture as well that the slope can be different, as well as the intercept. So what we might do as well is to include not only the intercept dummy to allow that the intercepts of the two groups to be different, but a slope dummy for the slopes to be different. Take account of that as well. Take a one step back. If we've got two lines, there's only the possibility as follows. There's no difference between the intercept and slope. In other words, the lines are identical. Another scenario is that the slopes are the same, but the intercepts are different. Another scenario is that the intercepts are the same, but the slopes are different. And the final scenario is that both intercept and slopes are different. Okay? So there's only one way that they can be the same. The other possibilities, the other three possibilities, is that the lines are different. In which case we could say there's a difference on the relationship of dose and length on the type of supplement taken. Okay. Now, how about if I wanted to include both of them? Okay. Well, the way we can do that is to use an interaction here. The dummy times the other x, and that will force in not only the intercept dummy for supplement, but also the slope dummy, as we can see as follows. That's dose. This is the intercept dummy, which has changed. Look at the figure, it's changed now. Is it significant? Yes. This is the slope dummy, 3.9. Is that significant? Yes. Now what does 3.9 tell me? It tells me that since VC has been coded 1, it tells me that for unit increase in dose, the impact on the dV, on the length of VC, will be 3.9 higher compared to just for a unit increase in dose on OJ. Okay, so you can see it's like an additional impact on length if you take VC rather than OJ, which is the thing that's coded 0. In other words, right, not in other words, I want to say then, looking at, but just judging by the t-statistic on the intercept dummy there and the slope dummy there, since they're both significant, it suggests that in terms of the difference, that the difference is in both the intercept and slope. Alright? And then finally, how about if we just want to see if it's just the impact of slope? Suppose we don't want an intercept dummy. Here we obviously do want intercept dummy. Suppose we don't want intercept dummy. How do I just put in the slope dummy? How do I adjust the code? We adjust the code like this. Just do at the end a minus sup, that will take it out. That's the same effect as the drop command. A minus sup, and there you go. Okay, so that is basically dummy variable. Dummy variable, the coefficient of dummy variable is used to compare the thing that is coded 1 to the thing that is coded 0. And another word for dummy variable is indicator variable. You know, so much jargon, we hate jargon, but it's even more so with this subject, because with statistics there's so many fields of application: psychologists, engineers, medical students, there's just biologists. There's just so many angles, people coming different fields using this kind of technique. They have their own jargon, and hence when I'm trying to teach it to you, I gotta kind of decide which one to use. So I'll have to let you figure out at times. Okay, well, I want to finish off by saying that since we've done the interpretation, I want to show you that other ways of generating dummies. See, with this way of just putting the sup in, we hadn't got control of what is coded 0 or 1. Suppose we didn't want VC to be coded 1. In other words, suppose I didn't want OJ to be the reference. Suppose I wanted VC to be the reference. How could I have done that? Well, you can do it with this other way. I generate a dummy, so let's call it D1 equal, and now I set a logical command, sup equal VC. This is saying that D1 will be set to 1 if for that particular observation the sup is equal to VC. Okay, so not equal to, it'll be D1 will be true if this statement is whole, otherwise it will be false. In other words, all I'm going to get is true and falses. Type D1 in now, see, true, 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 all the way to the 30th observation, false otherwise. But we know the first 30 were VC there. So there you go. And if we were to put this in to the regression, R would translate these trues and falses into ones and zero automatically. Suppose you don't like that. Suppose you want to actually see the ones and zeros beforehand. You would use the as.numeric command like this. Okay, so the as numeric, if this statement is true, it will turn the true into a 1. Otherwise it'll turn it to 0. Let's look at it. There you go. Finally, if we want to be sure that it is indeed that R is going to treat it as though it was a categorical independent variable, here we use the factor command, factor, and then the name of the X variable that we want to treat as if it was categorical, and then we'll interpret that, and the groups of the factor here is called the levels. So this is basically, kind of ANOVA speak. So the categorical variable, which is the X variable, is called a factor, and the groups of that factor are called levels. So here you've got 2 levels, OJ, VC. Alright, so that's about it for dummy variables. Of course, this case we've treated it simply because we are categorical variables has 2 levels. We can kind of carry this over to if we'll have more than 2 levels. Okay. Alright, hope that's been helpful.